The purpose of this demonstration is to show how the standard deviation can affect the shape of a normal distribution. Now right now we have the standard deviation set to be 1 here, and we can see a basic shape of a normal density. Now I have multiplied this by a multiplication factor of 10 so that we can easily see this curve. Now if I were to increase the standard deviation to 3, we can see here that the curve has gotten shorter, its peak has dropped down, and the tail ends have gotten a little bit wider. So when you increase the standard deviation for a normal density, you seem to make the curve kind of shorter and have it display fatter tails, if you will. And if we were to decrease this to, let's say, 0.3, we can see that the curve now has very, very thin tails, but it also has a very, very tall peak, okay, all the way past 13 in this case. So when you have a very, very small standard deviation, the normal density has a very, very tall peak and very, very thin tails here. So we kind of refer to this as tall and skinny. And the reason why this is because standard deviation represents dispersion of data. And when you have a very small standard deviation, the data is not very dispersed around the mean. It's kind of bunched up around the mean. So it makes sense that if you have a large standard deviation, that you would have the data more spread out, and therefore the normal density would reflect this spreading out of the data. Whereas if you take a smaller standard deviation, you get a curve that has a very tall spike and very, very thin tails here, because now all the data is being bunched up around the mean. And this is how the standard deviation can affect the shape of a curve, specifically the normal density.